welcome to episode 14 of Cloud Tech 10 for the 12th of June 2017. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. OpenBSD is now supported in Azure virtual machines. OpenBSD is a free Unix-like operating system focused on strong security. It's commonly used as the base for security software, including firewalls. Bringing support for OpenBSD also brings support for products such as the ESDN-era Firewall 3, a next-generation firewall built on OpenBSD, which is now available in the Azure marketplace. You can easily create an OpenBSD image that can be used to build OpenBSD IaaS virtual machines in Azure. Here I've got an OpenBSD version 6.1 server running in Hyper-V. This is a standard installation created by downloading the ISO image from the OpenBSD website, booting the Hyper-V VM from the image, and then performing a straightforward installation with default values. This server is already configured to use DHCP, but if it wasn't, I could use this command to enable it. I need to configure a serial console, which I do with these two commands that update the boot.conf file. Then I configure package installation. Next, I need to install and configure prerequisites for the Azure agent. This will install Python 2.7, OpenSSL, and Git. Once they're all installed, I run these commands to set up some links. Next, I use the git clone command to download the Azure agent files onto the server, and then I run the setup script to install and start the agent. Once that's done, I can use the ps command to check that the agent is running. Finally, I run the wa agent command with the deprovision user and force parameters. This will prepare the server to become a base image by removing SSH key pairs, disabling the root password, and removing other configuration items. At this point, the server is prepared for imaging, so we can shut it down. The next thing we need to do is convert the Hyper-V VHDX image to the VHD file format used by Azure virtual machines. We can do this in PowerShell with the convert VHD command. Now we're ready to set up Azure to deploy this virtual hard disk as an image. We'll use the Azure CLI to complete these steps. We need to create a resource group where we'll keep all of the resources related to this. We need somewhere to store our image file, so we'll create an Azure storage account in our resource group. The next few commands will need to know the access key details for the storage account we just created. So to keep things simple, we use the AZ storage account keys list command and save its output in a variable. The query at the end of this string will ensure that only the value of the first key is returned, and specifying the output type as TSV will strip unneeded quotation marks. So now the storage key variable contains our key. Let's create a container to store our VHD image file. And finally, we can use the AZ storage blob upload command to copy our VHD image file up to the Azure storage account. Depending on the size of the image file that you created, this could take some time. And we're done. Now all of the resources we need are in Azure. So I'll switch to the Azure portal and use the Cloud Shell to deploy an OpenBSD based virtual machine. We simply need this one command. We're providing the name of the resource group that we created earlier, a name for the new virtual machine, the details of the image file that now resides in our Azure storage account. This parameter indicates that we're not using managed disks for this, and we tell Azure that this will be a Linux virtual machine, and provide a username and an SSH public key. This takes a few minutes to complete, but once it's done, our OpenBSD Azure virtual machine is ready to use. The IP address of the virtual machine is provided in the output of the VM create command, but if you missed it, you can get the address using the VM list IP addresses command. And now we can SSH into our OpenBSD server, and that's it. We now have an OpenBSD virtual machine running in Azure. Using customer managed keys with Azure Storage Service Encryption is now available in a limited preview. The ability to encrypt data at rest with Microsoft provided keys has been available for some time now, but this update now allows you to bring your own keys. This feature works in conjunction with Azure Key Vault. You can either create your own encryption keys and upload them to Azure Key Vault, or use Azure Key Vault to generate the keys. This is a limited preview, so you'll need to sign up for access by sending an email to sscdiscussions@microsoft.com. Once accepted onto the preview, you'll need to create a new storage account. When that's done, go to the storage account and the encryption section. If you're successfully enrolled in the preview, you'll see the Use Your Own Key checkbox. Select the Use Your Own Key checkbox and you'll then be able to provide the details of the Key Vault instance and the key you want to use. Storage service encryption with your own keys is now set up and ready to use. Azure Analysis Services now comes with a new sample model to enable you to get up and running and explore the service more easily. You can create a new instance of the Azure Analysis Services via the Azure portal. Choose New, Data and Analytics, and then Analysis Services. You'll need to provide a server name, a resource group, and location, and select a pricing tier. The D tier is for development and ideally suited for evaluation, development, and test scenarios. Once the new instance has been created, click on New Model and you'll see Sample Data. Click Add and the sample model will be created. Once that's been done, you can explore the data model. Clicking on Open in Excel will download an Office Data Connection format file that can be opened in Excel. This provides a pivot table which you can then drill down on to explore the data held in Analysis Services. Or alternatively, you can use Power BI Desktop. Launch Power BI Desktop, choose Get Data, and then click More. From here, you can choose Azure and then Azure Analysis Services Database. You'll need to provide the name of your Analysis Services instance, which can be found in the Azure portal. Then select the AdventureWorks database. This will establish a live connection from Power BI to your Azure Analysis Services instance, and you can explore and visualize the data as required. The Data Science Virtual Machine is now available as a Windows Server 2016 based image. Currently, a Windows Server 2012 based image is available, as well as images for Linux based on Ubuntu or CentOS. The Data Science Virtual Machine is a customized virtual machine designed for data science and comes pre-configured with a wide selection of popular tools. To provision a new Data Science Virtual Machine, search for Data Science Virtual Machine, then choose the Windows 2016 preview option. Configuration is the same as for any Azure virtual machine, with a server name, virtual machine disk type, username and password, and resource group needing to be specified. Then select the type and size of virtual machine you want to create and configure storage and networking. The virtual machine takes a few minutes to deploy. Once it's ready, you can connect to the virtual machine and start using it. You can see here some of the pre-installed tools, including Power BI Desktop, Visual Studio Code, SQL Server Management Studio, RStudio and Microsoft R Open, Julia, Anaconda, Azure Storage Explorer, and more. The full list of tools installed on the Data Science Virtual Machine can be found at this location. That's all for Cloud Tech 10 this week. Don't forget, tell your friends, like, share and subscribe, or follow me on Twitter. I'll see you next week. Cheers for watching. Thanks for watching. If you enjoyed this video, don't forget to like, share, subscribe, and follow me on Twitter for more.